Well, hello everybody. Long time no see. Excuse a little bit of noise in the background. Actually, I just turned off my ultrasonic cleaner as well. I thought that I would make a video showing you guys what I go through. This is kind of an extreme scenario case of all the things that you could potentially need to do when you get an old amplifier in for service. Now, in front of me, I have a no-name, American-made amplifier from the late 40s. The chassis is actually already out of it. I decided to do this video after I already had kind of started checking everything out. But I'm going to take you guys through the process of deciding what to replace, which in this case is quite a bit because this amplifier is very old and very original. But I thought I'd take you through the cleanup a little bit and show you component replacement selection, stuff like that. So right now I am doing a bunch of cleaning of this old case. It's actually kind of cool. It is painted rather than Tolexed, and it's got this really neat sort of silver fleck thing on it. It looks like it's probably original to me, although I see brush strokes in the paint, so I really don't know for sure. But I'm going to start cleaning this up here. Now, one thing of note on this case, on this amplifier, sorry, is that I am going to be removing the speaker. It has a couple of tears. It looks to have had some repairs over the years that don't look super great. It's kind of neat. This is a dual 6v6 output. It's got two 6SC7s in the preamp. 5v4 GB rectifier, and then two 6v6s with a 12-inch speaker. A lot of these had pretty small speakers in them, so it's really cool to see that. The output transformer, again, as is standard in the old stuff, is mounted to the speaker. It is from the New York City Transformer Company, and if the date codes are the same on it as they are in many old amplifiers, the date code on this puts it at the 35th week of 1948, which seems right to me, especially with all the octal tubes. This was before they used the 9-pin tubes in the preamps, like the 12AX7s, 12AT7s, and things like that. But at this point, like I said, just trying to give this a good, respectful clean. I do see that this wood has been broken at some point. It seems like somebody already glued it back together, so I may just end up leaving that alone. But personally, I'm never happy with one of these jobs unless I make them look good. I don't think they should just sound good. I think they should look good too. So just a little bit of elbow grease and care. I do see some glue residue here, so somebody has fixed this cracked one in the past. Well, let me bring you back in on the chassis, and we'll talk about that on the bench. Welcome to my super messy workbench. Alright, so here we've got our chassis. This sits down in the bottom of the box. It just has one control on it. It's a volume control, and it's also the on-off switch. And I'm just going to kind of get right into considerations for what I do. So I pulled this out of the chassis, and I start looking at it, and immediately you can see that everything in here is completely original. Nobody's ever been in here. Now, these electrolytic caps, without even testing, I can tell you are garbage. The paper and oil caps in here that are used for like cathode bypass caps, things of that nature, they're going to be crap too. They're just so old. Even if they look good and even if they test okay, I know that once they get full voltage in them and things start heating up, that these have a tendency to just explode their insides out. Very similar to what would happen in an electrolytic capacitor. Now, this is the main filter cap for the incoming power smoothing, and the power smoothing for the different nodes within the amplifier, which is essentially different points of voltage that all need some amount of filtering so that they block DC and allow the AC guitar signal to pass through. So this cap can is garbage. Once again, I'm not even going to test it. Nobody makes these anymore. So I am going to have to install terminal strips inside of this case, which I've already talked to the customer about all of this. I'm going to have to install terminal strips inside of this case so that I can put modern axial capacitors in here for the filtering. It's kind of funny. You see things like this, and this is where technology was in 1948. This is the Mighty Midget. It is a 25 microfarad or 25 UF at 25 working volts, and the modern equivalent, let me go grab one here. The modern equivalent for this capacitor is this. So you can see there's quite a bit of size difference between the old one and the one that's going to go in and replace it. It's pretty wild to me. That never fails to sort of blow my mind. But the case is dirty, but it's in really good shape. The thing about the circuit in this is just the absolute simplest, everything you need and absolutely nothing you don't need in this amplifier, which is kind of cool. It makes it very easy to work on. Now, I've gone into this and I have tested several of the resistors in here, and they're all wildly out of spec. I think this amplifier got pretty good use over the years because everything seems to have drifted pretty far out of spec. So I will be replacing the majority of the resistors. Essentially, the circuit inside of this amplifier, all the components that have jobs in here are not doing their jobs anymore and all need to be replaced. Now, if you get a different amplifier, if you get something newer, there are more considerations you have to make for things that you're going to need to replace and things you're not going to need to replace. And let's walk over. I've got a 1977 Fender Twin Reverb that I did an estimate on, and we'll look at that and I'll kind of show you some of the things that I decided to add into the estimate for that amplifier. In fact, I'll grab it and we'll come back to the bench. Actually, another thing of note that I should talk about is this has a non-polarized two-prong plug on it, and it has no fuse. So when I do all of the service work to this, I will be removing this cord. I will be adding a fuse holder in the chassis and installing a grounded three-prong cable in here, and wiring it properly to modern safety standard the way that it should be. There's just no safe sense in leaving any of this kind of stuff in these old amplifiers. And we can talk about my philosophy on some of that here in a minute, because I think that's really important, and I think that it's something that more of us should talk about. But let's grab that other amplifier and we'll look at that. That moment when the chassis is so large you have to move your camera back so that you can get the entire chassis in frame. This is a 1977 Fender Twin Reverb chassis. It has what is called an ultralinear circuit. It has a humongous power transformer over here. Probably weighs 12 pounds all by itself. These are a little bit of a special circuit in the way that they send power to the screen grids and to the output tubes. And I'm not going to go into a whole lot of detail on that, but I'll show you kind of my first thoughts when I open something like this up. So the first thing that I did was I pulled out all of the tubes that were in the amplifier. It was missing 2 of the output tubes. I tested the ones that were in it. They're okay-ish. One of them has a measurable amount of grid leakage. So it's going to need all 4 of the output tubes replaced. All of the preamp tubes actually tested strong, so that's great. I get in here, immediately see that somebody has been in here, and I'm going to grab the camera here, so we're going to go into shaky mode. Immediately upon getting into this circuit, I can see that somebody has been in here and they have recapped the preamp section of this amplifier. Now, they use decent quality caps. I think when I was looking at them, they were Nishikons. Yeah, they're Nishikons. Phenomenal quality caps. The problem is that many people don't recognize that simply heating up one of the eyelets, you can pull the lead directly out of the eyelet and remove the old component. But what I see way too often are people who simply snip off the ends of the old ones and do this little hook and loop thing to put the new ones in. That's not the right way to do it. And it's kind of funny because I would initially want to say that that's a lazy thing that people do, but actually I think it's more work to do it that way. I don't know why people do that. Those caps are good, but I don't know when they were done, and it wasn't done well, so I will be replacing them. If it had the original caps in there, they would probably still be getting replaced, because electrolytic capacitors only have so much life. They're not magic, and they need to be replaced. And we're going to talk a little bit about that magic stuff here in a little bit. So, the other thing that I did when I got into this amplifier is I started measuring the values of the screen grid resistor and the grid stopper resistor that are on each of the output tube sockets. The 470 ohm screen grid resistors are all, once again, wildly out of spec. Now, back in the day, it was the norm for amplifiers to have only carbon composition resistors, which means that the track inside of the home material that these resistors are made of is carbon. Now, they work great, but they don't stand up to heat very well, and the longer that they are heat cycled, the worse they get. They were never really the best option for amplifiers, but again, it was what was around, and it was what was inexpensive, and so that's what these amplifier companies were using. So all of these have gotten hot. They're super out of spec. They're not doing their job properly anymore, so I'll be removing these screen grid resistors and replacing them. Now, the grid stoppers that are also down in here are also carbon comp. However, I have measured them and they are all within spec, so I will probably be leaving them in place because they are still in spec. That's one of those things, you can either do it or not do it, just depending on, you know, needs must. Now, this amplifier is currently owned by a local pawn shop who wants to get the amplifier working. And I feel it is my duty to do as good of a job as I can so that whoever buys this gets an amplifier that they know that will be reliable and that they can trust, out in the gigging world. So those will be getting replaced as well. Now, once everything up here is done, the recap's been done, all of the pots have been cleaned, the inside of the chassis has been cleaned of all this really gross goo in here. I'm also going to be scraping the board. Another thing you may have heard while looking up vintage Fender amplifier stuff is that a lot of these boards were actually dipped in wax before they were populated at the factory. And they did that to try to stop moisture from getting into the boards and causing any sort of DC to get out of the eyelets and be present on the board. The problem is that it actually made the problem worse. So over the years, dust and all sorts of things get embedded into that wax and actually make the problem worse. So what ends up happening is I will do a lot of meticulous scraping inside of this entire board and cleaning it thoroughly with isopropyl alcohol to drive all the moisture out of the board so that it works properly and we don't have any stray voltages anywhere on this board where they shouldn't be. So that's really the main portion of the inside of this amplifier. I will be replacing the original power cable. One thing to note, and if you're a tech, you'll see this a lot, is these particular power cords that have the red ends on them. The material they're made with is not very good, and it does not stand the test of time. In fact, this one has frayed on the ends and come out of the inside of it, which is, it's just not safe. It's just not good. So it'll be getting replaced. The other thing is back in the day, these amplifiers all had a switch on the back for ground. Now, if it's in the middle, there's no ground connected at all. If it goes one way, the hot and neutral lines are coming in one way. And if you flip it the other direction, the hot and the neutral are reversed and they're going the other way. That's not good. That's not the way we want things to be wired here in the modern day. So when I put in a new power cord, I will be disconnecting this switch from the circuit completely. The neutral will be going directly into the transformer neutral. The hot will be running to the fuse. From the fuse, it will be going to the switch, and from the switch, it will be going into the transformer. That's the way modern safety code is. That's the best way to ensure the safety of the electricity in the amplifier so that if anything goes wrong, it is going to blow that fuse and keep you from electrocuting yourself. So that's everything up here. Now, when the person who recapped this preamp section did so, they ignored the fact that the most wear item on any amplifier, and definitely an old vintage Fender, are the filter capacitors. Now, these filter capacitors do the same thing as that really large one that I showed you in the other chassis, except that one is just a multi-section where there's multiple taps within one unit to give you different capacitance ratings. This one has individual capacitors. Now, these have all aged. I am sure that they are on the verge of leaking or venting, and I'm going to replace them all as both a precautionary measure and just as a longevity measure. Now, you're going to look at my face because we're going to talk about this some more. There are an absolute buttload of people out there who will tell you that you don't need to replace the electrolytic capacitors in an old amplifier just because they're old. I don't agree with that, and here's why. The companies who manufactured these electrolytic capacitors said hey, even if these aren't being used, if they're sitting on the shelf, for every year that they're sitting on the shelf, they're losing capacity. The inside of an electrolytic capacitor is generally some paper and some foil material that is tightly wrapped, put into a can, and then an electrolyte solution is soaked into that paper. Over the years, the water or whatever liquid component that the base of that electrolyte liquid is made of dries up out of the capacitor, and the capacitor can no longer function as intended. You might get an old amplifier where you'll try to turn it on and immediately notice a lot of That's because you are hearing an electrolytic capacitor that has failed, and it is no longer filtering as the power is being run through it, as the voltage, the current, whatever word you want to use, whenever electricity is going through it. And the job of an electrolytic capacitor, first and foremost, is to smooth any ripple, because electricity, when it comes out of your wall, is what we would call dirty. It's not a beautiful, pretty sine wave, which is what it's supposed to be. They do enough filtering to allow all of your home appliances and things to run just fine, but the electricity is, in effect, kind of dirty. If you look in any of the items that you plug into the wall, you would notice that the incoming power section in anything, including your tiny little cube cell phone chargers, little USB blocks and things like that, have capacitors that are for the purpose of smoothing that electricity out so that it is a more stable sine wave without a whole bunch of hairy stuff on top of the signal. So they do a very important job. And in tube amplifiers that are running, 3, 4, 500 volts of power through them, it is very important that they are healthy. Now, I have heard many times from old guys, mostly, that you can reform old capacitors in these vintage amplifiers. Like, oh, I got a 1954 Fender amplifier, and heaven forbid I would replace any of the electrolytic capacitors, because those are the originals. They're amazing. I've heard so many of these stories where guys are like, well, I replaced the electrolytic capacitors with modern equivalents, and the amp doesn't sound, it doesn't sound as good, or it doesn't sound the same anymore. Phooey on that nonsense. They have a job to do, especially in the filter section of an amplifier. None of this has to do with the final audio coming out of your amplifier. And those caps are old. They're not doing their job to the best of their ability anymore. They are on their way out, and nothing that you can do to them is going to save them. It is true that if you are going to power something up that is very old, that hasn't been on in a long time, it's best to use a variac. If you absolutely must turn it on to test it, put it into a variac, start the voltage low, and bring it up very slowly, and that'll allow those capacitors to slowly sort of come back to life. If you just hit them with wall voltage right away, you do run the risk of having one blow up and possibly cause other issues inside of the circuit at the same time. Now, that's fine if you're testing, but ultimately, if this is an electronic device that you are going to be using, if you are going to turn it on and play music through it, replace the electrolytic capacitors. They are not made of magic. As you can see, the technology has changed and advanced quite a bit over the years. That 25 at 25 that I showed you versus the new one I'm going to put in, which is much tinier. I showed you this earlier. This is actually rated for 50 volts, so it's actually the same capacitance rating, but it's rated to handle higher voltages than what was in that initially, and it's just going to do a better job. But in general, the technology, the tolerances are much tighter. The quality of the materials that went into them is just more scientifically advanced. Which sounds like sort of a ridiculous thing to say for something that's, considered to be old tech like a tube amplifier is. So I could test these capacitors and decide whether or not they are still in spec and leave them in here, and I'm not going to do that. I'm already in the amplifier servicing it. I know that these capacitors are 45 years old, which for an electrolytic capacitor is double their sort of the advice that manufacturers give for these capacitors is generally about 20 years. Back when these were being made, they definitely did not have that kind of lifespan, or at least the manufacturer wouldn't have told you that they would have lasted that long. So there's no reason to keep these caps in here. I very much am of the mindset that none of these are museum pieces, and if you are having it serviced because you are going to be using it, it needs to be serviced in a way that allows it to work at its best possible potential. If you're going to put it in a museum, then just don't have it serviced and go put it in a museum, which I think is a completely worthless thing to do. They made hundreds of thousands of millions of these amplifiers over the years, and your amplifier is not special. It doesn't need to be treated with kid gloves. Either service it properly and use it, or don't service it properly and don't use it. That's the way I feel, and I get really sick and tired of people being so precious about, old Mallory capacitors and things of that nature. There are phenomenal companies out there now who are making capacitors that are significantly better quality than these were, and there's just no reason to leave them in an amplifier. They are not magic. They have a job to do, and they either do that job or they don't. So that is my very long. There's probably other things. As I get to talking and get in my own head, I have a tendency to ramble and kind of miss some points that I'd like to make. But all said and done, electrolytic capacitors are not magical. They have a job to do, and they need to do that job. And if you're going to use your amplifier, you want the components in that amplifier to be doing their job the best that they possibly can. And the only way to ensure that's going to happen is to make sure that those components are fresh and doing their job as good as possible. Period. So that's kind of some thoughts. When I get one of these amplifiers, I always tend to go the extra mile. I generally don't charge people for the extra time that I'm going to spend in their amplifier cleaning things. And I don't know where this amplifier has been, but it has this very greasy something all over it. I'm not even sure what it is, to be honest. The caps do not look to be venting at this point, but I would imagine that they're probably not far off. And once again, they're 45 years old at this point. There's just no reason to keep those in there. 39th week of 77. I believe this one was the same. 39th week of 77, 35th week of 77. So there you go. There are some other little things I'm going to do in here. I'm replacing the lamp piece. It's no longer fitting properly in the front panel. The new repros are just as good a quality as the originals. Like I said, I will be going in here with isopropyl alcohol. I'll be scraping the wax off this board, all that stuff. But those are just some of the considerations you need to make. Now, if something's been recapped, and you get it and you find it like this, in essence, I could leave those capacitors in. They're probably doing their job. I don't know how old they are, but the job wasn't done right. And for me, my hands will have been in this amplifier, and when I put my name on a little sticker, or when I put a sticker on the back of this that says that it was, you know, serviced in March of 2024, I want to, I want the person who gets it to be able to be confident enough in this amplifier working properly, that the service was done the right way, that the amp is going to work for them properly. And if I'm ever going to attach my name to the service history of an amplifier, I want to know that everything has been done properly and is in good shape. Those capacitors, I think I charge $1 a piece for the 25 at 50s that go into the preamp sections of these amplifiers. It doesn't add a lot of extra time. As it is, I think I quoted 3.5 hours for this job. Principally because there's a lot of cleanup that needs to be done on this. The cabinet, which I haven't even shown you, also needs work. The speaker wiring was redone at some point and not done well. So there's a lot of considerations to be made. Again, I just want to make sure that when this amplifier finds its new home, that somebody can plug it in and use it and not have to worry about whether or not it's going to do the job properly for them. So I will do everything I can to make sure that it's going to do that. And yeah, that's my soapbox. But this Gibson amplifier, I will be getting back to it and showing you sort of some of the process of working on it and getting it up to spec. I think I just said it was a Gibson amplifier. It's not. It's very similar to a lot of the Gibson amplifiers that were made back then, but I actually don't know what it is. Again, there's no company anywhere on it. All I know is that it's got US made transformers. There are many companies that it could potentially be, but we will get to that. So that's pretty much all I have for you today. I'm going to come back with another video soon. Once I get parts in for the other amplifier, I will show you the work on that, and we'll get some final tones and all that fun stuff. So take all that and do with it what you will.